Hello, everybody. This is Psychology 3280, Week 1 lecture of the Neural Basis of Consciousness. I'm your lecturer, Professor Nao Tsuchiya, and this week, in this first video, I will go over the organizational overview of the class. All right, so let's come to the third part of week 1 lecture. This is going to be the actual contents of the lecture for the week 1. After week 1 lecture, you will be able to answer the following questions. Why are we interested in consciousness? What do we mean by consciousness? How can we study consciousness? What are the potential problems when one wants to understand the test and the possibility of consciousness in interesting cases such as animals, plants, and robots? So, why are we interested in consciousness? Well, this question, although I ask you guys to do this type of the why questions, it's actually quite difficult to do if you have never thought about what problem of consciousness is. But if you have ever wondered any of these questions, you will understand why this is very strange and interesting questions. So what I mean by that is such as the question of why do we feel the way we do? And why do we lose consciousness when we go to the sleep? As you actually understand more and more about the brain and how the conscious experience differs from non-conscious processing, these two questions actually becomes more and more strange and difficult to answer if you are asked by any other person on the street, or if you have a kid, or if your parents ask the same question. But more easier kind of question to understand why this is interesting is, for example, if you have ever wondered whether you are experiencing the world in the same way as other people do. In fact, one of my earliest question that I remember as a sort of consciousness researcher is this particular question: is my yellow the same as the yellow that other people are experiencing? This is a question that my friend in my junior high school asked on the way to go to the school. And then we spent 10 minutes, 15 minutes to the school, and then discussing about this question. And we ended up in concluding something like, okay, if I'm experiencing yellow the way I'm doing right now throughout the development, then I actually don't know what it's like if my yellow is like your blue, for example. And if everything is switched for my yellow and my friend's blue, then probably nobody can actually detect any difference between blue and yellow experience if ours are swapped. And I will try to go to this kind of, sort of a philosophical debate at some point when we don't talk about the color experience in week 3 or 4. But at the moment, I believe that there is a way out to go this sort of, philosophical questions of inverted Fourier argument. But we'll see how we go in the future lectures. And another question, which is relatively also easy to understand why this is important and interesting, is that what it was like when I was a baby. Everybody was once a baby, and nobody really remembers how it was like when you were a baby. The first memory of your experience is usually second year or third year of the life, and typically it accompanies with some emotional experience. In my case, I remember the first conscious experience was when I hit my back of the head at the door, and then I bleeded quite a bit and went to the hospital. And that pretty painful experience, and also the experience of my mother holding my head like this and then going to the hospital was the really clear, vivid, imagery that I have, and it's a real experience. And probably you guys also have something like that. But before that first moment of the life, what it was like, it's quite unclear from my own. But if I look at the baby right now, for my daughter and sons are already like 10 years old, so it's not it's like 10 years ago, but it's quite difficult to believe that there was nothing there, before 2 or 3 years of life. But it's very difficult to imagine what it's like. And we will discuss about this type of the baby experience at some point in the lecture. And now, also, the same kind of question can be addressed to what will it be like when I'm going to die? Everybody also, after getting born and several years, from now, or maybe tens of years from now, you're going to die at some point. And probably many of you, or maybe some of you might have thought about what it feels like to die, depending on how you die, but it will potentially feel nothing or potentially feel something, depending on your spiritual or religious kind of belief. But what I'm interested in is neuroscientifically speaking, what it is like to be if you are dead, okay? And we also touch upon this kind of question or near-death experience in some of the week 2 for tutorial papers. And also another completely different kind of question is like what it's like to be an animal. The most famous philosophical question is called what it's like to be a bat, which has ultrasonic devices as a sensory device, unlike us. Is it like vision or is it like audio experience? That has been debated in philosophy. And also, I'll also talk a little bit about the insect's brain, especially flies, into the future lectures. But do you think that flies, for example, feel anything or not? And what kind of structure of consciousness they have potentially in common with us or not? That's really interesting question. What about plants or robots? That's also becoming quite interesting questions, which also has some real world implications. The importantly, consciousness is the only way you know what the world is like. Most of you probably assume that there is a world out there in the first place, and then we are born to this world and then observe or experience the world. However, that's one potential worldview. But if you are actually completely unconscious when you are living throughout the life, if all of your brain activity is completely non-conscious, doesn't give rise to conscious experience, then there is actually nothing in the world because there's no experience to begin with. It's also a little bit of philosophical way of telling you this problem, but it is a fact that in terms of knowledge, consciousness is the only way you can actually interact and know about the world. You can't learn or you can't live any experience through unconscious processing. And that becomes also clearer as we go into the next lecture. On the other hand, so the consciousness has been recognized as such, very, very important and central to our life. But as you may have, thought about, conscious experience is, as sometimes called, subjective experience. It is different potentially for each other people, and sometimes, let's say, for me, rose smells very good, but for my wife, it may sound, terrible or something like that. These kind of subjective difference in experiential quality has led to many people, philosophers and physicists, to doubt about the reality of this conscious experience. And that has led to many of the philosophers and physicists to leave aside of the problem of the consciousness, such as Galileo Galilei decided to, okay, the consciousness problem is totally subjective and a bit difficult to deal with. So let's avoid dealing with this type of the question, and then focus on something that is purely objective outside of the world. Something that we can all agree about the world. And this type of the attitude has led to a big success in science, and in particular technology and medicine. Now, all the technology in medicine and science, which completely disregards science, can still make a huge success in making our life better, and also, clinical, medical devices work and so on. Cell phone and so on doesn't have to rely on anything about conscious experience to explain these devices. On the other hand, this has led to the negligence of the consciousness on one side, and this is not really a good state of the affair, actually, which many of the philosophers and scientists have thought at the same time. And I'll briefly talk about the quantum mechanics, but in particular field of the physics, or a particular type of other fields, this has always led to a sort of the incomplete picture of the world. For example, if we can explain everything of the physics of the world without referring to consciousness, it's really weird that something in the brain does generate this conscious experience, but there's no way to explain how this conscious experience actually emerges from the brain. And that means that we cannot make a prediction about what the plants are feeling, what the animals are feeling, what the iPhones are potentially feeling, or anything like that. We don't have laws of consciousness in physics right now. But we will talk about the potential theory in the lecture towards the end of this series. Okay. This same kind of thing also applies to many of the concerns, such as whether the conservation of the energy laws in physics does it apply to consciousness. When you go to sleep, brains are actually highly active, and still your experience is gone. Does it mean that something also has to reduce, or has to be conserved in some way to make up this imbalance? We actually don't know. And also that this has led to various kind of questions about the interaction between conscious experience, subjective world, and objective world. And we will talk a little bit about free will or decision making in the week 2 tutorial, but also this has led to the question of how our experience interacts with the world. And as a result, at the moment, we have not a really good, sort of the explanation or a strategy how to deal with consciousness from in the medicine or technology side. So, for example, in the medical situation, we'll talk about a little bit in this lecture, but focusing on language or behavior of the patient led to the medical technology that completely disregard our conscious experience. And from the patient's point of view, that's really horrible. And we can, in fact, experience, what it's like to be a patient by, getting some kind of anesthesia where you just can't move, but everybody else, observing yourself will treat you as sort of completely unconscious, but in your brain you are experiencing everything, and also you are hearing what others are saying. You just can't move. You are paralyzed. It's a really scary kind of thought experiment, and in fact, it is actual experience of some of the patients of damage in some particular parts of the brain. In fact, last week or so, there was a paper published reporting one patient who has been treated as vegetative states for 20 years, but in fact, that patient seems to have been conscious for these 20 years. It's really scary, but this is the consequence of treating the behaviors or language or any kind of outputs of behaviors that we can treat is the only target of the science. And technology-wise, it's the same thing. We have to take into account of subjective experience. Otherwise, drugs and so on, even if it treats the overt behaviors, such as, let's say if you are taking the pills and then suddenly you become better at, sort of the managing the task or moving, but if your internal experience becomes really horrible because of the drugs, then you don't want to take it. But as long as the medicine and technology doesn't treat conscious experience seriously, this kind of thing can happen in the future. So to give you a brief history of consciousness research, as I mentioned, this type of the subjective experience has been always discussed in philosophy because it is very important in terms of our life. And then in 1644, René Descartes, this figure on the left, published Principles of Philosophy, and then here he discussed about cogito ergo sum, known as I think, therefore I am. It is, in a sense, the declaration of the centrality of conscious experience. In this case, he says I think, but you can take it as an I experience, therefore I am. And then starting from the late 1800s or so, several prominent psychologists, experimental psychologists, started doing some kind of psychological research quite seriously, like Wundt, Fechner, and William James, and talked about consciousness at that time. So that was the first part of learning object. By the way, I try to always put the bottom right as a sort of learning objective, well, which part of the lecture corresponds to which learning objective. And this part is going to be what is consciousness. So the consciousness has been used in at least two ways in our everyday language. The first one is level of consciousness. And by that, what typically clinician uses this term of level of consciousness means is that if it's fully conscious, that means that you are wakeful and alert. On the other hand, if you lose consciousness, or if you are in the low level state of consciousness, that means that the coma or vegetative states that we, at the moment in the scientific research of consciousness, we do not have any conscious experience. Coma and vegetative states, you don't have conscious experience. This is important, and this is kind of thing that I'm going to ask in the quiz, okay? And anesthesia, there is different kinds of anesthesia, and the type of the anesthesia called general anesthesia, when the dosage of this general anesthesia is very high, then you lose consciousness. If you have experienced some kind of amputation or some major surgery, this is a thing that you do, and here you also lose consciousness completely. And then unlike this type of the general anesthesia, you actually have loss of consciousness in some part of the sleep, deep dreamless sleep. And I'm going to talk about this again into the future lecture. So this level of consciousness is one thing. And another type of the consciousness is called contents of consciousness. And in this sense, people sometimes use the term such as awareness. Awareness is usually meant to be something that is reportable, if you want. The contents of consciousness that are reportable is called awareness, okay? And then qualia, feelings, what it's like, or conscious perception, all of these things are more or less meaning the same thing as conscious contents. And this includes a self-consciousness of various modalities such as sound, vision, tastes, and thinking, and so on. everything that you are conscious of is called the contents of consciousness. Here is a two-dimensional diagram of a level of consciousness and the contents of consciousness proposed by Steve Rorius. There is this is a diagram proposed in 2005. So there has been some revision of these things, but roughly speaking, as your level of consciousness increases, you can have a potentially many different kinds of contents of consciousness. That's what this kind of diagram starts to mean. And the coma, general anesthesia is very, very deep and low level of consciousness, and the deep sleep, no dreams, or general anesthesia is roughly really like this. And then fully conscious is high level of consciousness, and also fully, rich contents of consciousness. Some of the interesting situations, such as sleepwalking, complex partial seizures, epilepsy, and vegetative states, are considered to be, in some cases, low level of consciousness and low contents of consciousness. And this particular figure categorized vegetative states as a high level of consciousness, but this is because in this particular paper, vegetative states are categorized high in terms of the and the overt behavior. So it's still utilized that objective measure of consciousness. From the behavior perspective, vegetative state looks like conscious. That's why it's to the right. But in fact, after so many years of the research, we currently think that vegetative states have nothing to feel, so it should be categorized to the left actually. Okay. So what I have been telling you so far is that there is lots of things to discuss about consciousness from the phenomenology side, subjective side of the experience. What do you feel in terms of levels and also contents? And then that only is not possible to study, but it can be coupled with experimental data or theories to explain that. And this triangulational kind of approach is the one that we will take in the Psyche 3280. So phenomenology, what do I mean by that, is basically contents of consciousness, or the whole contents of consciousness, what you are experiencing right now. And here I recommend you to watch the video of motion-induced blindness. Okay, so the reason why I say that is that we usually do not know about the structure of conscious phenomenology. So let's go there. In this video, you will see a bunch of moving blue cross here in the background, and then three dots, three yellow dots, which is very visible. And then what you're gonna do is to fixate at the center, this green blinking, dot, okay? And then focus on green dot without moving your eyes. What happened to your yellow dots? That's the question. Okay. I'll let you observe it for a while. Once again. Okay, you do it again. Fixate at the center, and then pay attention to, without moving your eyes, pay attention to yellow dots. What do you observe? And if you have any family or friends at your, close distance, maybe, send this video or watch it together, and then make sure what happens to other people. Okay, I hope you experience it. Okay, so what's the point of showing this motion-induced blindness? Why did I show it to you? That's because I wanted you to understand or appreciate how much we know about conscious phenomenology. You might think that, when you are looking at something that is so salient, such as, yellow dots on a black background, should not become invisible. But if you are like me, hopefully these yellow dots probably disappeared from your conscious experience, on and off. And this kind of thing is actually happening in the everyday life. In fact, if you are riding on a car, or driving a bicycle or motorcycle or something like that, if there is some stable things presented at the periphery, even if it's like a very salient light, yellow light and so on, you don't actually sometimes that disappears from conscious experience, and you don't notice it sometimes. But wow, how do you know that something disappears from your consciousness is an interesting question in itself. But some people have discovered this type of salient situation. So, and also, I want you to notice that this kind of experience is common across many people, like your friends or family or others, but timing of this disappearance is probably not the same. Everybody has some bias towards, right side disappearing more or left side disappearing more. And also, interestingly, if you pay attention to the yellow dots, then that disappears more. And something that is we discuss towards the in the lecture on attention and consciousness. Here, it's a very interesting situation where attending more makes things disappear. And this is very difficult to understand if you do not understand, the structure of consciousness phenomenology per se. And that's what we want to understand in this lecture. Okay. Okay. So now, after observing the motionless blindness, I want you to think why yellow dots become invisible, and also try to pay attention to one of the dots, and then how it actually affects on the visibility, and experiment yourself. And then also for those people who do not see the illusion, consider why this could be the case. But as a sort of a hint to experience illusion, you really focus has to to be on the center of the dots, and then do not make eye movements, and also try not to blink. And then most of the people will see these yellow dots disappearing. So not only the motion-induced blindness, there are lots of illusions that illuminates the structure of our conscious phenomenology. And these are the cases that are clarified in many of the visual illusion links here. And we will also refer to that in the later lectures in week 2, 3, 4, and also further on, because these are the very potent tools for consciousness research. And also it's fun as well. And then other types of the approaches to the conscious phenomenology is to investigate the individual differences, either developmental or genetical issues, and also brain lesions acquire differences in consciousness. And also, even for you or me, you can also alter the conscious experience by studying the consciousness under the different states, such as inattention, or under the anesthesia or sleep. Also, to understand the consciousness, we need a multi-level approach. So just focusing on the phenomenology per se is not necessary or sufficient. And one big component is definitely experimental data coming from the brains, and the brains of the humans and the animals. And these are composed of various components, which I'll review a little bit today towards the end of the lecture, which is neurons and population of neurons, how these neurons are connected and so on, and then compose big areas of the brain, such as frontal lobe, occipital lobe, parietal lobe, temporal lobe, that I'll review later. And then within these local neurons, how they are connected and so on. And this will give us some hint about what the consciousness is. And the more important thing by learning actually brain is that you realize the problem of the non-conscious neural activity. It's a bit surprising, but the more you study the neurons in the brain, it becomes clear that how much is not related to conscious experience. We'll go into the detail in the lecture into the future, but it's sufficient to say that the more you learn about the brain, you actually get amazed why we have to experience a world like this. And then, of course, another type of the experimental data is coming from the behaviors or reports or cognition, thinking kind of stuff in humans and animals. And the most, prominent thing is the verbal reports that can potentially, convey the most complex type of the experience. But also, especially important types of the communication or experimental data comes from the bottom responses and so on, and complex behaviors. Not only the verbal or bottom responses, like video recording and things like that. And all of this again points to the problem of non-conscious processing. It's not the case that the simple behavior is non-conscious and the complex behavior is conscious. And that's something that you will also study through the assessment 2 and 3 reading assignments and presentation. And culmination of all this is the combination of brain and behaviors through neuroimaging studies of humans. So in roughly around 1990s, there was an explosion of empirical study of consciousness using a neuroimaging. So here, like the figure on the right side, experimenters now started to record the brain activity using a method called functional magnetic resonance imaging, fMRI, and then see what kind of activity can be observed while people are experiencing one thing or not. And that could include, for example, showing them motion-induced blindness to yourself, and then lying on the scanner, and then your brain is monitored throughout. And then you report, oh, now I see yellow, and now I don't. And now I attend to the left, and that disappeared, and things like that. And all of these behavior reports are now correlated with the brain behavior, brain activity to find out the neuronal correlates of consciousness. And one of the biggest breakthrough through this type of the experiment is the finding by OM 2006. Here, he did the brain imaging of a patient who was diagnosed as a vegetative state for a really long time. And by the clinical definition, vegetative state is considered as a completely, unconscious state. However, the parents of the patient and also the medical staff who are working on this patient for a long time suspected that this patient may be actually conscious. And what the Owen did was the ingenious experiment to this patient. So what they did was to put the patient into the fMRI scanner and then ask the patient to imagine two types of the scenario. One is playing tennis or walking around the house. And then to their surprise that when they asked to imagine playing tennis, that the patient was able to activate the part of the brain that is usually activated when people imagine, playing tennis like this. And by the way, the dentation of the frontal part of the brain is related to the, car accident that he had, and you can see that, this type of the, that brain damage is going to be really, destructive for your consciousness. But still, he was able to activate this part in reaction to the request to play, imagine playing tennis. Remember that this patient was not able to move the body at all. And then on the other hand, when the patient was imagining walking around the corridor of the hospital or home, then a set of the brain regions that are related to navigation and imagining the scenes are activated like this. And the later study even showed that this pattern can be used as a yes or no answer to the question that only patient or family can understand or answer correctly, but the experimenter cannot. So this is a very striking example of the brain imaging showing the presence of consciousness for the first time, which was assessed as non-conscious clinically or behaviorally. Now, so to summarize the approaches that has been taken since 1990s, this is the so-called new search for the neural correlates of consciousness, NCC. Okay. Um, we assume as we started with, there is some kind of outside world, and then that is processed by sensory organs in the brain, such as eyes or ears and so on, and then somehow that is uh, converted inside the brain into the electrical activity of the brain, neurons or chemical activity in the synapses that I'll explain later. And then some kind of the neural activity in the brain correlates with the experience of seeing a particular dog or thinking about a dog and so on. And this subjectivity or consciousness is correlated with this conscious particular part of the brain activity. And finding such correlates is one effective way to study consciousness. And this type of the stuff, trying to find the exact correlate of the neural activity that correlates with conscious experience is categorized as a so-called easy problem. Easy in a sense that is in principle possible to do according to some philosophical kind of criterion. Basically, you can also rephrase it as explain observable behaviors from the neural activities. Seeing, yes, I saw dog, or I'm thinking about dog, kind of report is now correlated with the neural activity, trying to find the correlational evidence between consciousness and the neural activities. And you can do that with a very different kind of the paradigm, such as, dissociating and manipulating consciousness through attention, or looking at particular part of the brain, such as the primary visual cortex V1, and whether there is any MCC, or recently there's a strong push of whether there is a conscious experience correlates within the frontal area, executive areas or not. And then mapping the MCC where, the conscious experience, what kind of conscious experience is mapped across the brain. If we can understand fully, then we can get to the understanding of consciousness. That's a sort of the schematic figure represented here. However, here comes this a philosophical challenge. So after a few years of explosion of empirical studies of consciousness through neuroimaging, David Chalmers, another philosopher, said, oh, no, that kind of an approach will never get to explain the so-called hard problem of consciousness. The problem of consciousness is hard, according to Chalmers, because this link from some particular neural activity to particular conscious experience, this red arrow, is really unclear why it has to be. What I mean by that is becomes much clearer as you become more familiar with the concept of the non-conscious activity. If you look at the brain, then any types of the brain's activity looks, from the experimental point of view, almost identical in terms of electrical pulse or chemical reaction inside the brain. Everything looks more or less the same in terms of components, but somehow under some kind of condition, it seems to correlate with the conscious experience, but not others. Why is that? That's really weird. And according to Chalmers' argument, basically, as long as we can imagine a world that says that this type of the neural correlates does not exist in some brain, then the mere possibility of thinking about that is sufficient to philosophically reject the idea of getting to build up all this evidence to get to explain why and how certain neural activity must give rise to consciousness. This must is the part, because it can be completely irrelevant for conscious experience, and unless we have this particular theoretical or physical sort of the laws to mandate requires particular activity has to give rise to consciousness, then there is always a gap between this mountain to the mountaintop. And what the philosopher uses is such as philosophical zombie argument or inverted quality argument, knowledge argument, etc. And all of these are inspiration of some of the papers that you will be reviewing in the tutorial in weeks 2 and 4. So if you can touch on that, that's excellent. But if not, that's also fine. So the mere conceivability of the philosophical zombie makes it hard to answer, why certain neural activity has to give rise to consciousness, okay? That's a sort of problem of studying consciousness in one sense. And the way to address this is potentially quite difficult. And many of the empirical consciousness researchers admit that, oh, yeah, hard problem is just hard. We can't just solve it. And that's one attitude. And another attitude that I take is to use this theoretical approach called integrated information theory. So here we try to reverse the arrow here, not to try to explain why this type of the neural activity has to give rise to this conscious experience. Rather, this kind of conscious experience is experienced. That's something that we already take it for granted. As I said, everything we know is only through conscious experience. And if that's the case, then let's say, in the case of the yellow dots in the motion-induced blindness, I see it right now and I don't see it right now. Okay, so there are two states of the conscious experience. And then what this theory says is that what kind of physical mechanism has to achieve such and such property of conscious experience. And I'll go more details of the integrated information theory and how it works in practice in the later part of the lecture. But this is one potential way to solve, the problem or hard problem. It's not solving this left to right arrow, which is hard, but from right to left to approach and make a progress in consciousness research. And you can consider it as a sort of the helicopter going from the top and then arriving at this answer of this problem. But of course, the helicopter needs to identify the location on mountain peak and so on. So all these empirical evidence is necessary to identify this peak. So combination of the top-down IIT approach and bottom-up approach of the evidence is the one that I take in my lab to resolve these problems of studying consciousness. Anyway, to summarize, IIT tries to come up with an explanation on how our conscious phenomenology can be supported by particular type of physical mechanisms. All right, so that's in my mind, another breakthrough of the consciousness research in answer to the Chalmers question. Tononi has proposed the integrated information theory of consciousness in 2004. There's a typo in here. Not only the integrated information theory, there are lots of progress in terms of theories, and we'll also touch upon other types of the theory. These theories are sometimes very useful to understand many observations that you encounter in the lecture and also tutorial. Over the last 30 years, there are lots of interesting progress made in the neuroscience of consciousness, and the theory helps us to coherently categorize all these findings. And the theories are used to explain standard data, but also it's used to make a counterintuitive predictions, and then to make things that are impossible to test, such as plants consciousness or computer consciousness and things like that. And in terms of your assessments, final research proposal can make a touch about let's say one particular test of the one particular theories or competing theories and so on. That will make research project more interesting and attractive. But in practice, how we do this, study of the consciousness within this, our lectures is to start from your own phenomenology. That's what I would first, strongly suggest. Think about why and how you lose consciousness when you go to the sleep or not. When you came up with the sleep, what is the difference between before and after you wake up. It's really interesting thing to, observe if you have never done that. And also try to discover, in terms of the phenomenology, what you don't know, okay? And then once you start to realize that, there are lots of things that are not known in this consciousness research, like Matt Might's slide, when you get to the boundary of the knowledge, then that's the sort of the chance to make a contribution to the research. And also that's the most exciting part of the consciousness research. So to come back with the assessment things, in the end, not only your research assessment, but also in practice, our consciousness research itself, after identifying the boundary of knowledge, propose a new experiments, and then based on theory, conduct the experiments and so on, and then come back to the theory. That's the sort of the cycles. And also, as I mentioned in the learning, broader learning objective of this course, we need to we will combine ideas from philosophy, mathematics, physics, and also information theory, but also many other areas as well. And these ideas or different kind of technology or perspective, even from arts or even from other types of fields like architect or something like that, that can induce a different kind of ideas, new ideas to refine the existing experiments, and that will lead to your final research report writing proposal. And then if you can make an experiment in the future, that will contribute to the field. So now to learning, how can we learn the boundary of the knowledge necessary to assess assessment tasks 2 and 3. So here's a really brief list of what we can do in terms of making advance in consciousness research. One is to study carefully brain injured patients, and another one is carefully characterize conscious phenomenology in the normal healthy patients, and understand the attention and the consciousness relationship, and also to get a deeper understanding of implicit processing or unconscious perception, and consciousness research in animals, and also actual direct recording from the brain in humans who can report experience. And some other method would include studies of the brains which are reorganized in some way or reconnected, and how the consciousness alters because of the reorganization. This is just a brief view, list of the research programs, but featured in assessment 2 and 3. To understand, finally, to address the questions you are going to be asked for week 1, I suggest to look at the glossary in Christoph Koch's book on the following entries, such as consciousness, contents of consciousness, qualia, non-conscious, awareness, coma, vegetative states, easy hard problem, mind-body problem, as well as cerebral cortex, and neocortex, contralateral, ipsilateral. Contralateral means the other side, and ipsilateral means the same side. This is anatomical terminology. We will use relatively extensively in some of the topics. And also, I'll briefly explain the neurons, such as action and its mechanism and phenomena, such as action potential, spikes, firing, as well as synapses and connections and so on, and dorsal and ventral pathway. Okay. So for the rest of the week 1 lecture, I'll just briefly cover very, very basics of the neural base of consciousness. And these are some of the necessary knowledge to answer fully for the quiz for week 1. And also, it will be useful for you guys to know to do the week 2 assessments and presentations. Let's get started with the anatomy first. So here's the brain image. And this is looking at my brain. For example, if you are looking from the side, and then this side corresponds to the frontal side of, so there is some eyes here, and then my brain would locate, bulging in the front and then going back. And then at the back of the brain, there is this cerebellum that contains actually much more neurons than the total of the cerebral cortex, which I'll talk about at some point. And these cerebellum are mostly non-related to consciousness and more related to motor coordination and so on, but it's also critical for language. And then there are four lobes, such as occipital lobe that is related to the visual consciousness, and the parietal lobe, sensory perception and movement, frontal lobe, decision-making, impulse control, judgment, emotion control, and the temporal lobe, side of the brain, related to language, sexuality, emotion, hearing, and memory. Okay. And here's an important anatomical terminology, which I'm going to also test with you in the quiz. The important thing is the directionality of these things, and this is always, utilized to name a particular part of the brain. So first one is the axis of the lateral side to the center, medial, lateral medial, and then anterior to posterior, front to back. Okay, and then dorsal and ventral. Dorsal is a side of the back of the body, as well as the top of the head. And then ventral is side of the stomach, as well as the the bottom side of the brain. Okay, so ventral and dorsal is kind of curved like this. And then when you talk about the cuts of the brain, such as this vertical direction, it's called this cut is called a coronal section. And then split to the left, to the right, and then looking from the medial side corresponds to this mid-sagittal section. And the horizontal section is relatively easy. You cut the brain from the, with the horizontal plane to the ground. And for example, we talk about dorsal, posterior, and anterior, and lateral medial, using to denote some particular part of the brain, such as ventral prefrontal cortex means ventral part of the anterior part of the frontal cortex, something like this, or superior upper part of the parietal cortex, superior parietal cortex, and so on. And if you focus and zoom on to one particular brain, which is the cortex is a piece of the sheet, two-dimensional pizza-like, thing, roughly corresponding to literally like medium-sized pizza, and then crush into folding in like an origami, and then put it into the brain. That's the sort of how the brain cortex works. But each of the piece of the cortex contains lots of neurons. And this is highly schematic depiction of how the neuron looks like. But one sheet of the cortex is a thickness of 1 to 2 millimeters in vertical dimension. And within 300 micromillimeter, there is a population of the neurons that does something similar in terms of functionality. It's called columns. And I'll explain it in later lectures. And each of the neurons is connected to other neurons through other, several mechanisms. And this is an important figure to understand for the quiz one. The cell body of the neuron is called soma, and that contains usually DNAs to make proteins and so on. And then the neuron receives the input from other neurons through these dendrites. It's called like trees of a tree part of the leaf part of the trees. And then when the information or spikes are collected enough at the soma, then neuron makes a decision to produce an output through axon. It's a sort of a cable-like structure. And then when the cable passes this electricity at the terminal, this electrical activity is converted into the chemical synaptic transmitter. And that's the part of the, the terminal is called axon terminals. And through the synapse, it connects to another neuron's dendrites. That's a sort of the basic architecture of one neuron.